Week 2, Unit 3, Solving Equations and Inequalities. What we're going to see here in these next several slides is the whole concept of algebra, which is based on balance. Algebra means balance in ancient Phoenician. The Phoenicians are the one who invented algebra, actually. And what you see is we're balancing one side of the equation to the other. Whatever we do to one side, we have to do to the other. Start with the addition principle. I got an equation here, 6 plus x equals 13. Well, you could say I know it's 7, but let's do it algebraically because these are going to get more complicated as we continue to go through this. I want to get all the letters on one side, numbers on the other. Here's my 6. I want to get all the x's on one side by themselves. There's one x here. So it's 6 right here minus 6. I subtract 6 from there. If I do it to this side, I have to do it to this side. 6 minus 6 is 0 on the left, and then 13 minus 6 is 7. X plus 0 is simply x, so x equals 7. Here's another one. X plus 5 equals negative 7. Get all the letters on one side, numbers on the other. So I got x plus 5 minus 5 on the left. And now if I do minus 5 on the left, I do minus 5 on the right. X plus 5 minus 5 equals negative 7 minus 5. Negative 7 minus 5 is negative 12. X plus 5 minus 5 just simply leaves x plus 0, or x. So x equals negative 12. And in the fractions here, we have to find a common denominator for both of them. Very difficult to see what we need to be doing without a common denominator. I got negative 2/3 plus x equals 5/2. Well, let's get all the x's on one side and the numbers on the other. Negative 2/3 x plus 2/3 x. On one side here, I add it. So if I add 2/3 to one side, I add 2/3 to the other. So I'm left with x equals 5/2 plus 2/3. I got to find common denominator. And for both of those, 2 and 3, it'd be 6. 5/2 equals 15/6. 2/3 is 4/6. 15/6 plus 4/6 is 19/6. Here are some examples here. Y plus 4 equals 11. We're going to subtract 4 on both sides here. Y plus 4 minus 4 equals 11 minus 4. Y plus 0 equals 7, or y simply equals 7. X minus 3 equals 14. Let's add minus 3 to both sides to get rid of that minus, plus 3 to both sides to get rid of that minus 3. X minus 3 plus 3 here, plus 3 here. So x minus 3 plus 3 is simply x plus 0, or x. And then 14 plus 3 is 17. So x is 17. Again, we have a fraction here. Let's get all the letters on one side, numbers on the other, and then we will find the common denominator. X plus 2/3 equals negative 5/6. I want to get rid of that 2/3 on the left. So if I subtract it from the left, I got to subtract it from the right. And when I put here, negative 2/3 is the same as negative 4/6 here. So I'm just going to replace that negative 2/3 minus 4/6. X plus 2/3 minus 2/3 is simply x plus 0, or x. And then negative 5/6 minus 4/6 is minus 9/6. And that can be simplified to negative 3/2. Similar to the addition, we have the multiplication principle. Now this is where we're going to use, we did the inverses before, now we're going to use the reciprocal. I don't have an x here, I have a 5x here in example 1. 5x equals 70. I'm going to multiply both sides by 1/5 because 1/5 is reciprocal of 5. And you'll see what will happen here. I want to turn 5x into x, so multiply both sides by 1/5 here. 1/5 on the left, 1/5 on the right. And that ends up being 5x over 5, which the 5's cross off, and I'm left with x here. And on the right, that's 70 over 5. 70 over 5 is 14. So x equals 14. Example 2, negative 4x equals 92. I'm going to multiply both sides by negative 1/4 to get rid of negative 4x. And by multiplying negative by negative, I get a positive because we want our answer to be a positive x. So negative 1/4 times negative 4x, right here, that simply becomes x. And then on the right side, I got the negative 1/4 again multiply. 92 times negative 1/4 is negative 92/4, and that is simply negative 23. I have a fraction here. 3/8 equals negative 5/4. Now I'm going to remind you that when we multiply fractions, we don't have to change the denominator, but we do have to find the reciprocal of negative 5/4. The reciprocal of negative 5/4 is 4/5. 4/5 times negative 4/5 of negative 5/4 is x. 4/5 times 3/8 is negative 12/40, which simplifies as negative 3/10. Here's some more examples here. 63 equals 9x. I want to turn 9x into x and multiply it by the reciprocal. The reciprocal of 9 is 1/9. So if I do it to one side, I have to do it to the other. 9x times 1/9 leaves 9x over 9, or simply x. The 9's cancel out. And on the left, 63 times 1/9 is 63/9, which is x equals 7. Example 2 got negative 15x equals 105. The reciprocal of negative 15 is negative 1/15. So when I multiply negative 1/15 times negative 15x, I get 15x over 15. The negative over negative is positive. 15 over 15 becomes 1, so I got an x on the left here. Now since I multiply negative 1/15 on the left, I have to do it to the right. 105 times negative 1/15 is negative 105 over 15, which is 7. And you can use your calculators for these. And here's a fraction. Negative 2y over 5 equals 4/15. I want to turn that negative 2/5 y into just a y. So I multiply by the reciprocal, which is negative 5/2. I have to do it to both sides because again I want to balance. Negative 5/2 here times 2y over 5 equals negative 10y over negative 10, which is simply y. The negative, two negatives become positive, 10 over 10 is 1. Now I did the negative 5/2 on the left, now I got to do it on the right. 4/15 times negative 2/5 equals negative 20 over 30. 4 times 5 is 20, 15 times 2 is 30. So it's negative 20 over 30, which can be simplified to negative 2 over 3. Now, what we did with addition and multiplication by themselves are called one-step equations. What I'm going to show you is using both of them. These are called two-step equations. And I can't always tell you where to start. Sometimes it's easier to do multiplication or the reciprocal. Sometimes it's easier to do with the addition or subtraction. You have to look at each individual equation. So let's look at this here. Example 1, 3x plus 4 equals 13. And I've got a multiple of x, which is 3x, and a 4. What I like doing is, let's first get all the numbers on one side and the letters on the other. So I got 3x plus 4. I'm going to subtract 4 on both sides. And that leaves me 3x equals 9. Now I'm going to multiply. That's my first step. My second step, I'm going to get rid of that 3x and turn it into an x. I'm multiplying both sides by 1/3. 1/3 times 3x simply leaves an x. 9 times 1/3, or the 1/3 on the other side, is 9 over 3, which equals 3. Example 2, negative 5x minus 6 is 16, another two-step equation. Let's get the letters on one side, numbers on the other. So I'm going to move that negative 6 by adding 6 to both sides. So that leaves me a negative 5x minus 6 plus 6. Simply using negative 5x on the left, and on the right, 16 plus 6 is 22. I'll multiply both sides for the second step by the reciprocal of negative 5, which is negative 1/5. Negative 1/5 times negative 5x simply leaves x. And then on the right, since I multiply it on the left, negative 1/5, I have to do it to the right. 22 times negative 1/5 is simply negative 22/5. And that's our final answer. Let's look at some of these problems here. Negative 5x minus 7 equals 108. I'm going to add 7 to both sides here. So I can just isolate that negative 5x. And that leaves me negative 5x equals 115. Now on both sides by negative 1/5, right here to make negative 5x into an x. And negative 5x over 5 simply leaves x on the left, and then negative 115 over times 1/5 is negative 1/15 over 5, which is negative 23. Now, this has a couple of variables here, but they're both the same variable, different, they're on both sides though. 14 minus 6a equals 2a plus 3. That's what I call a three-step equation. Because you can do several steps at one time. I don't like doing that. Easier to make a mistake. So the first thing I'm going to do is I want to move some numbers over. And I've got 14 minus 6a equals negative 2a plus 3. I'm going to subtract 3 here. So subtract 3 on this side. I can subtract 3 on this side. 14 minus 3 is 11. That leaves me negative 2a plus 3. 2a. Because 3 minus 3 is 0. I got rid of it. So I got 11 minus 6a equals negative 2a. Now I'm going to move 6a to the other, negative 6a to the other side by adding 6a to both sides. You do this with variables as well. So this gets rid of on the left here. So negative 6a plus 6a is 0. I add a 6a on the right. Negative 2a plus 6a is negative 4a. So 11 equals negative 4a. I want to turn that negative 4a into an a. So multiply both sides by negative 1/4. Negative 1/4 times negative 4a simply leaves, two negatives become positive, simply leaves an a here. And on the left, negative 1/4 times 11 is negative 11/4. So a equals negative 11/4. Example 3. I gotta multiply this all out, but no different. 8 times the component of 3x plus 2 equals 30. Well, let's multiply the 8 times 3x plus 2 out first. 8 times 3x is 24x. 8 times 2, that's 8 times 3x. 8 times 2 is 16. So I got 24x plus 16 equals 30. Let's get those x's on one side and numbers on the other. So I'm going to subtract negative 16 from both sides. Or say add negative 16 to both sides. So that cancels out. 16 minus 16 simply leaves 24x. And then 30 minus 16 is 14. So I got 24x equals 14. I'm going to multiply both sides by 1/24. That turns into 24x over 24, which simply the 24's cancel out. That leaves x, and then 1/24 times 14 is 14/24, which is x equals 14/24, which can be simplified to 7/12. Last one here, and it's a little more complicated, but no different than the last step we did in example 3. 7 times 5x minus 2 equals 6 times 6x minus 1. Let's multiply those out first. 7 times 5x is 35x. 7 times negative 2 is negative 14. And on the right here, 6 times 6x is 36x. 6 times negative 1, negative 6. So there is my equation multiplied out. And like I said, you can do multiple steps. I like doing it one at a time. So what I'm going to do is I'm going to add 6 to both sides, get rid of that negative 6 on the left. So if I add 6 here, I got to add 6 here. Negative 14 plus 6 on the left equals negative 8. And on the left here, on the right, is 36x. So now I'm going to subtract 35x from this 35x and move it to the other side. Subtract it from one side, I got to subtract it from the other. So 35x minus 8 equals 36x minus 35x. 36x minus 35x is simply x. And all I'm left with here is 8. So negative 8 equals x. Now, when we have formulas, these are often just all letters, but it's the same principle. We can rearrange them to find out certain components. We do this a lot within the electrical world and the medical world, where we all have unknown things, but how is one component of an equation related to the other ones? So suppose I have here distance, rate, and time, where distance equals rate that someone's moving, let's say a mile an hour, times time, and they move in 1 hour, so they move in a mile in an hour. But we don't get t alone, the time alone. D equals RT. Here's my original equation. I want to find just t. So I want to get rid of that r right here by multiplying times 1 over r on this side. If I do it to that side, I have to do it to this side. And 1 over r times d is d over r. RT times 1 over r is RT over r, but the r's cancel out, and we're left with t. T equals d over r. Here's a couple more examples of multiple variables. Y equals x minus 10. We got to solve for x. Well, let's move the x to the other side because I don't like the negative x. So y equals 10 minus x. I'm going to add x to both sides here, and I got to do it here since I'm balancing. So y plus x equals 10. Now I'm going to get rid of that y. Y minus y, and here this side means I got to subtract from this side, 10 minus y. So I'm left with x here equals 10 minus y. Example 2, solve for y where by equals ax. Really what we're doing here is we want to solve for y. We can get rid of that b. So by getting rid of the b, we multiply times 1 over b here. And again, if I do it to one side, I have to do it to the other. by over b is by times 1 over b is by over b. Those cancel out. All left is a y here. And 1 over b times ax is this right here. So simply, our answer is y equals ax over b. The third one is actually very simple. Solve for c where a equals a plus b plus c over 3. And it looks so scary because c is part of a numerator in a fraction. But what I'm going to do is I'm going to get rid of that 3 in the denominator. It's the same as a third. By multiplying times 3 on both sides. If I do a 3 on one side, do 3 on the other. And what we're left with here is 3 times a plus b plus c over 3. The 3's cancel out since they're multiplying out. So I'm left with the equation 3a on the left equals a plus b plus c. Now in this case, I'm going to subtract I got the a plus b. I'm going to subtract a minus b, or negative a. I'm going to subtract minus a plus b minus b plus c, because I'm trying to get the c by itself. So if I subtract negative a here and negative a here to get rid of that a on the right, and negative b here to get rid of the b on the right, I have to do it to this side too. So my final answer is 3a minus b equals c. Now we talk about percents. These are very simple actually. We want to know what amount of one number is of a total number. When what percent $32 is of $50? Well, all we're going to do is we're simply going to divide 32 times, make a denominator for the larger number, 32 times 1 over 50. And that ends up being 32 over 50. When I divide in the calculator, we have to do that. That's 0.64. Multiply that 0.64 times 100%, which is 1, just renaming it, equals 64%. So our percentage is 64%. Here's some other examples with application of percents. 1% of 76, which is our total number, is 19. 19 divided by 76 equals 0.25. 0.25 times 100%. And remember, 100% is still just 1. We're just renaming it. 0.25 times 100% is 25%. 57 is what percent of 300? 57 divided by 300. 300 is a larger number we're dividing by is 0.19. 0.19 times 100% is 19%. Now, when we have problems that we're trying to solve, this is an issue with a lot of people. I understand that. No one likes word problems. But I remember, read through it. And more important than anything, in addition to these notes here about translating the problem and solving the equation, and then checking it, look for what they're asking for in terms of the unknown. If you can figure out what the unknown is, and they're giving an answer on the other side of a total number, you know how to set up your equation. Let's look at some of these. A knitted scarf with an orange section, a red section, and a dark red section. The red section is half the length of the orange section, and the dark red section is 1/4 the length of the orange section. Total length of all three sections is 7 feet. So let's define our unknowns. We don't know how long any of them are. But it said the red section is half the length of the orange section. So we'll call the orange one x. That means red is 1/2 x. It also said dark red is 1/4 the orange section. So it's 1/4 x. And we know all three sections make up 7 feet. Orange plus red plus dark red is 7 feet. And I've already said orange equals x, red equals 1/2 x, dark red equals 1/4 x. So x plus 1/2 x plus 1/4 x represent orange plus red plus dark red equals 7 feet. Let's add all those x's up. X plus 1/2 x plus 1/4 x is actually 1 3/4 x. I'm going to turn 1 3/4 x into 7/4 x. It's just easier to solve this way. And so that means 7/4 x equals 7 feet. I want to turn 7/4 x into just simply x now. And what that allows me to do is turn it into simply an x and solve my problem. 7/4 x times 7 feet times 4 sevenths. If I do 4 sevenths on one side, I have to do 4 sevenths on the other. 7/4 times 4 sevenths is x. Or I would say 4 sevenths times 7x over 4 is x. And then 7 times 4 times 4 over 7 is 28 over 7, which is 4. So my x is 4, which means if that's 4 for orange, that means the red is half of it, which is half of 4 is 2. And then dark red is 1/4 x, and that would be 1/4 of 4 is 1. 4 plus 2 is 6 plus 1 is 7. So we have solved our problem. Here's another one. A 240-inch pipe is cut into 2 pieces. One piece is 3 times the length of the other. Find the lengths of the pieces. So I got 2 pieces of pipe, and one is 3 times the length of the other. I don't know what it is, but I know one piece is x. The other one would be 3x. And x plus 3x is going to equal 240 inches. 3x plus x is 4x. 4x equals 240 right here. I'm going to multiply 1/4 to turn that 4x into an x. And I do it to one side, I have to do it to the other. 1/4 times 4x simply leaves me an x. 240 times 1/4 equals 240 over 4, or 60. Now let's see if this works here. 3 times 60 is 180 if my x is 60. And then the other piece is just 60. 180 plus 60 is 240. Now, the last thing I want to cover is solving inequalities. Inequalities are solved the same way as an equation. When we talk about inequality, that is a greater than or less than, greater than equal to, or less than equal to. However, we solve it the same way as an equation. X plus 2 is greater than 9. Well, I want to get to the x's on one side and the numbers on the other. So I'm going to do minus 2 on this side, and I have to do to this side. X plus 2 minus 2 is 0. Simply left with x. And 9 minus 2 is 7. So x is greater than 7. Y minus 9 is greater than 13. Let's get rid of that 9 by adding 9 to both sides. So y minus 9 plus 9 leaves y. Negative 13 plus 9 equals 4. So y is greater than negative 4. 8x is greater than or equal to 32. 8x is greater than or equal to 32. Let's get rid of the 8x by turning it into x. We multiply it by the reciprocal of 8, which is 1/8. 1/8 times 8x is 8x over 8, which reduces down to simply x. And then if I did 1/8 on the left, multiplying it, I got to multiply it by 1/8 on the right. 32 times 1/8 is 32 over 8, which is 4. So x is greater than or equal to 4. Here's a two-step equation here. 13x minus 7 is less than negative 46. Let's get rid of that negative 7 by adding 7 to both sides, here and here. I'm left with 13x minus 7 plus 7, which is 13x, is less than negative 46 plus 7, which is negative 39. So I'm going to multiply both sides by 1/13 to get rid of that 13x into an x. 1/13 times 13x, that's 13x over 13, which is simply x. They all cancel out. So x on the left. Negative 39 times 1/13 is negative 39/13, which is 3. So x is less than negative 3. Now we apply this also in equalities. You have to use some wordsmithing. You have to basically read through all the components of it. And these aren't simple, I'll be the first to admit, and it takes some logic and practice. Example 1, the temperature is at most 2 degrees. That means it can be 1 degree, it can be 0 degrees, it can also be 2. It can be equal to, but it can be at the most 2 degrees. It can't be 2.1 or 3 or 5. So the temperature is less than or equal to 2 degrees. Example 2, 5 less than 1/2 a number is greater than 17. Well, I'm looking at the simplest parts right now. Greater than 17. There's my greater than. There's my 17. 5 less, so it's going to be a minus 5. And the number, if we said of a number, we know what it is. We'll call that x. And it's half a number. So 5 less, so we'll go 1/2 of a number and 5 less than that. So it's 1/2 x minus 5 is greater than 17.